Hello, folks. Welcome to a somber occasion. Our last class together. Oh, I was like, it's not, my chat isn't making any noise. I didn't hit connect on my chat robot thing. Forgive me, I just finished eating dinner. I don't think I have it on my face. Hopefully not. I'm generally pretty good about not wearing my food. Anyway, hello everyone. Welcome. It's that time. It's time for announcements. Let me close some stuff here. I got stuff open that I don't want to have open because it's in my face. Okay, where we at? Here. Cool. All right, let's get to it. Let's do it to it. Welcome. Okay. Announcements. It's announcements time. As you might guess, nothing really new today. Just some reminders. Am I getting emails? Yes. I responded to every email that I've gotten up until yesterday, I think. I did get a whole bunch of emails today. And I've had a busy afternoon trying to catch up with it. So, like a lot of people have been missing deadlines and stuff. And so trying to deal with those situations is really awkward. I don't like it. Yep, it was like a couple hours ago, right? Earlier this afternoon. I saw you amidst the flood of emails that I got today, so I'm sorry I haven't gotten to it yet. I want my face up in the corner. Okay. There we go. Okay, so... Oh, wait, I don't want it in the corner. I had this issue earlier, and I forgot about it. Let me move my face. Cool. All right, so... quick refreshers on some stuff. Last day tonight is the night of nights. Last day for the University Climate Studies Survey. Available at that link. Linked right there. That's the purple thing. Click on it. Or it's purple on my screen. It'll be blue on yours. And the end of semester evaluation surveys. I have not looked at the results in the last 24 hours, so I don't know an up-to-date number. I won't guess. But I did send a note to great, good to hear it, Daisy. I did send an email to 20-something students last night who hadn't filled it out yet. So that is more than 20% of my students. So we did not have 80% as of last night. I haven't looked at it today, so I don't know. So please get those filled out if you haven't done it yet. So if you didn't get an email from me yesterday, and you're sure you didn't get an email from me yesterday, you should have already filled it out. But if you did get an email from me yesterday, make sure you get that done. Okay, so MindTap, Chapter 8, half credit. If you do it today, it was due yesterday. If you get it done today, it's half credit. Chapter 9 due tomorrow night at midnight. We're going to do quiz 2 in a second. Can I open exam 2 for you? We can talk about it. That ship has sailed by quite a bit, but we can discuss outside of class. This is not the time. That was like 2 weeks ago. But a bunch of students just weren't participating in class at the time, so I don't know. We can talk about it. In class assignment 3, don't forget about this. That'll be available tomorrow through Friday. I got a practice exam posted, reminded on the format for quiz 3 and the remaining exams. 3 attempts, best one counts. Each attempt has a time limit. Practice exam 3 only has 1 attempt. That's not right. Okay, I'll get it fixed in a second. Attempt timer cannot be paused. So you start a timer and you have an hour, 2 hours, whatever the time limit is to fill it out. Whether you leave and go to the bathroom or not, timer still ticks. There's your schedule, same dates as before. Quiz 9, Tuesday, Wednesday. Exam 3, Tuesday, Wednesday, Thursday. And final exam Thursday through Saturday. I will try to have your final grade up through exam 3 on Friday. So I'll have everything else put in and fill it out. So there's going to be some itemized columns and a final average. So I'll try to make it as obvious as possible. Okay. That's all refresher. There's really nothing new in this, so just kind of reminders. Just reminders. Okay. You sure do. You absolutely do. Okay. We got a couple minutes. Not that. Practice exam 3. Yes, that one. Okay. Assessment? Which one? What's it under? That one. Huh. I wonder, do I have it wrong on my other class? Let's see. That's important. I might. Because I don't think I went to the assessment tab. Ah, I do. Thanks. I'm glad you noticed that. That was not intentional. Okay. Now, we've got a couple more minutes before the exam. However, there's one thing that I want to make very clear. And it's been an issue the whole semester, but students have largely ignored it, and it's mostly worked out. However, that is no longer the case. So this is not new, but apparently I've been told that a lot of students feel like it's new because they've been ignoring it this whole time. And that is rounding, the way that rounding works. So if you had a lot of trouble with the in-class assignment because you couldn't get any of the answers to work out, it was probably a rounding mistake. So I emailed several of you or talked to several of you on Discord, not just your class, but across both classes, with this issue because it was rampant that there were problems across the board. So what should you round? What should you not round? If you are taking a value from a table, don't round. There's no reason. It's already rounded for you. And I think with t-tables and z-tables is either 3 or 4. Yes, you will need those. They are in the exam prep materials folders, which it says so in the description of the questions. Exam prep materials, normal table, t-table. They're right there. So those are the files that you need. You can get them from the textbook. You can get them from Google. It doesn't matter. It's the same information. Can I explain how to use it? You're in luck. I've got a whole video on the topic in the links to online resources. But anyway, I'm trying to tell you something important, okay? Take those table values as they are, 3 or 4 decimal places, depending. I think it's 3 for t-tables, 4 for z-table. Doesn't matter. Whatever it is, take it off. Use it directly. If you're adding or subtracting, there's really shouldn't be a reason to. It's not going to change the number of decimal places you have, so don't round for that. But anything else, you should be rounding. So multiplication, division, square roots, power, exponentials, these kinds of things, you should be rounding to 2 decimal places. In case you're doing it by hand on your paper or whatever calculator you have, it doesn't matter. We'll all get the same answers by rounding each step of the process to 2 decimal places. So I found that a lot of people have been very confused by this. So normal distributions, z-table is in here, and then I want to say t-tables is either in there or in sampling distributions. I don't actually remember. You can look in the book and see where it is, and then it'll be in that exact spot. That's the easiest way. Or you can scroll through the slides and figure out where it is in the slides. And that's just a generic policy, by the way. Anytime you have a question, I wonder if he can explain this thing again. So the t-table itself, but how do you use it? So I'm trying to think the first time that it came up, which is the first time that it came up is it's either chapter 6 or chapter 7. So anytime you have a question, the easiest thing to do is to go back. If the name, oftentimes the name is just here. No, you can. You absolutely can. There's no reason why you can't. You can. So if the name's not obvious here, then look in the lecture slides and see where it is in the lecture slides, and then that'll tell you where it is, and then you can find it in the video. So like t-tables, z-tables. There are several examples in the slides of how to use the tables, like with the little animation arrows and stuff, and then there's stuff for the there's like verbal explanations as well. That's what I'm trying to say. Okay, Point estimator. Well, unfortunately, the quiz is open, so I can no longer answer questions. So, it's that time. There are not multiple standard errors. The quiz has begun, folks. Quiz is open. 7:20. So these are the same questions as they were in class assignment. So Okay. It is 7:40, sorry. 7:40. I have my computer set to Central Time, but my phone, which I have on a charger in front of me, which I have as a dock for my Twitch dashboard, shows 8:40. Apologies. This thing has a cable clamp. I had no idea. Oh, I'm so about to use this. Oh, it's kind of useless. Okay, never mind. Well, anyway. Okay, so I know several of you have questions. I'm willing to work with you. General comment. Remember, these are the same questions that were on the in-class assignment. So what I was hoping would happen is we would try to sort all this out over the weekend. And I got a bunch of emails yesterday, and I replied to them yesterday evening. And yeah, so I can go through and check for partial credit on this one. I did that for my other section. I'm not going to be doing it going forward. It's important that we learn to follow the system. It's just rounding everything, round every step. We can deal with that. Send me a message on Discord, and I'll see what I can do. Same thing for Ramzina. Yeah, and other questions, like if you have an issue with these questions, there are other example questions in the book, or when I say book, but more importantly, there are examples of these things in the lecture slides. So, yes, part by part. Which again, like this was the system before the coronavirus. This isn't new. I've been doing this, but in the past, I've been using multiple choice. And with multiple choice, as long as you were close, you could kind of figure out which one that I wanted. You can't get away with that now because we have a better system than multiple choice. Yes, I'm calling this a better system. I prefer this to multiple choice because there's not a 25% chance of you just guessing correctly by mistake. So it's requires you to know more. It's hard for that reason. So this has been the policy. This is how I've been making the keys the whole semester. Round each step to 2 decimal places. So in MindTap, I don't have control over that. I do have control over that for the D2L stuff, which is why I said to round all calculations. So that's what I mean by rounding all calculations to 2 decimal places. MindTap doesn't tell you to do that. MindTap, truth be told, is a lot smarter than D2L. I'll just put it out there. Right. Correct. The reason for this is that D2L is not very smart. The D2L quiz system kind of sucks. I really don't like it. There are several things that I want to do that I can't. And so I have to put in the exact answer. It does not know how to do rounding. There's only one way I can put things in where it knows how to handle rounding. And so I'm pigeonholed on what I can do if I'm going to have rounding incorporated into the assessment. And it's not worth it. It feels like it really messes with what I can do. So this is what we're going to do. And you just have to do all the steps individually. So, like I said, now this is you're right. This is not applied to MindTap. So that's why I tried to make the point before the quiz as well. And I told a bunch of people, like in Discord or an email over the weekend, that make sure you're doing the rounding thing. So I'll go back and look at it. I'll go back and regrade all the quizzes manually. It'll take me several minutes, so don't expect it to be immediate. I'll get through it. So I will take off a half a point if you did not round correctly, but I'm not going to regrade it in the future. So make sure you understand. Can I give one example? Okay, when you divide, round to 2 decimal places. That's one example. Same. Daniel. That's Daniel, right? Daniel. Let's talk after class. Several people have missed a lot. There are a few students that pretty much haven't done anything since coronavirus. We're not going to fix it in class. Okay. Wait, you don't miss what, Ben? Mind tap? Sorry, I had to remember first name from last name. Oh. Yeah. I didn't say round up. Round. It's not the same thing. It may be that you're not rounding correctly, which is another point. I have that happen a lot. Students make rounding mistakes frequently, which this is a good thing to practice. Rounding correctly is important. I'm sorry if this is detailed. Math is detail-oriented. So this is a good skill to be practicing. Okay. All right, so part of the reason we're not going to do examples is because we have one more thing we need to talk about. Wait, before. On the quiz? No, you had 3 attempts. But they were all in the 20 minutes. So remember, you have attempts within the window. Do the square root first, round 2. Yep. Then divide, round to 2 decimal places. Yep. Multiply the values that you just did by the table exactly. Yes, and round. So there's no reason to round a table value. It's already been rounded. You can redo it? You shouldn't be able to. Did I mess it up? Oh, good. You can't redo it. I'm glad that's how that works. Okay. So yes, do the square root, round. Do the division, round. Do the multiplication, round. The only thing, addition and subtraction, like you can round them if you want. It doesn't matter. The number of decimal places doesn't change when you add and subtract. So, round, I guess. Doesn't matter. The only thing you shouldn't round are the table values. They've already been rounded for you. There's no reason to just round off like a decimal place. The main point is so that we all agree on a number. I picked 2 because it's easier than doing 4. I could have done 4. I went too fast in the unknown. There are more examples in the slides if you want to go through them. And if you have a specific question, I'm happy to work with you, but we're not going to backtrack in class. So check out the videos. If that's not helpful, flip through the lecture slides. There's more stuff in there. And if I'm just talking too fast, you can slow it down. That's a thing you can do on YouTube. If you didn't know, I'll show you. Oh, geez. I'm going to hit buttons. YouTube. What should we watch? Ooh, Simone Gertz. It's probably really loud, isn't it? Okay. Settings. Playback speed. I don't recommend this, but you can. More likely you'll do like 0.75. Or more likely, you'll do this. So, that's the thing you can do. Okay. Oh, gosh. My face isn't that good to look at in regular speed. I don't want to see it in slow-mo. Woo! Oh, well. That'd probably be funny. I'll laugh with it. You send me some shots. I'll feature it. That's funny. Okay. So, guys, not saying that I'm not going to help you. We're just not going to do it right now. We're not going to do it right now. If you start having a conversation in Twitch chat about it, I will time you out because you're distracting everybody else. All right. So my point is that what I want you to do is start with the videos. And if that's not enough, maybe you flip through the book, maybe you flip through the slides, then ask me. But I thought I'm hearing things. Oh, no, my cat is here. Okay. Whew. Thought I was going crazy. Anyway, start with those places. And if you still have questions, you can let me know. Like I want to be helpful. I'm not trying to say I'm not going to help you. But we're not going to do it in class. I wish we had more time. I really, really do. But we don't. We have 28 minutes in the rest of the semester. Exactly. That's what the class Discord was for. I've considered, like, almost no one talks on it. I've gotten 5 or more DMs a day of people asking me questions. If you put it in the class Discord, my answer is useful for everyone. So, like, I put in specific examples for the rounding multiple times in DM Discord and Discord DMs. But I felt awkward, like, taking that person's question and just, like, calling them out in the chat and be like, this person asked me a question. I didn't want it to sound like I was making it sound like you're stupid. So if you just ask the question in the chat, then anybody can help you, and anyone can benefit from the conversation. So that's the thing we can do. Go to Discord, go to your class things, type in there. And you can, like, if someone sends you a message, you can be like, boom, right click, and you can quote it. And, like, reply to it and stuff. There's cool stuff in here. And you guys want to have a chat? You got meeting rooms. Just pop in one, say hello. I have no idea what's happening right now. Oh, is this the new Discord now has video? Wait, I did not ask for this. I don't like that at all. That's a headache. Why are you doing this to me? I just want to be in the voice chat. Okay, so single click, no video, double click video. Okay, that's interesting. That's a thing you can do. Huh, okay, I learned something new. It used to be you double click to join. So that's in the new Discord update from, like, yesterday. Anyway, that's a thing. That is a thing that I can do. Okay, 25 minutes. Let's, in the words of Blue's Clues, let's think. Okay. So, pretty much, Chapter 9 is an extension of Chapter 8, which is an extension of Chapter 7, which is an extension of Chapter 6. So, if you're thinking, oh my God, I don't have Chapter 6 down, there's videos. We're going to go ahead and move on for the day. We got to cover it. But you can go back, look at videos. If you have any questions, ask them in the Discord. We'll get you sorted out. I promise. Okay, so where are we? Where did we leave off last time? So last time we spent the majority of our time talking about null and alternative hypotheses, because this is actually the main new thing. This is pretty much the big new concept of this chapter is hypotheses. Because if you can define the hypotheses, then you're basically creating your own Chapter 8 question, or really Chapter 6 question? Yeah. So if you get the hypothesis part right, you now have a Chapter 6 question. So that's why we spent time on that. And that is how a lot of the homework questions are. If you haven't done the homeworks yet, that's how a good portion of the Chapter 9 questions are, how they are on the quiz, how they are on the practice exam, and so on. It shouldn't be blurry. I think it's coming through clearly from my end. I've got a green status light on my stream quality, so I think it's on your end. The good news is that if you if you're having trouble reading the slides, most of the text is pretty big. If you're having trouble reading the slides, you can always follow along on your own copy of the slides. My face being blurry might be an advantage. I don't like looking at it. Got a hot mess going on down here. Speaker cable, mic cable everywhere. Okay, so we did all this stuff. Null and alternative hypotheses. Remember, the null hypothesis, H0, H0, is a tentative assumption about a population parameter. And remember what I said before, it's innocent until proven guilty. Okay? We're going to extend this law metaphor here in a minute. Okay, so null hypothesis, H0, tentative assumption about the population parameter. Alternative hypothesis, HA, is the opposite of what is stated in the null hypothesis. Oh, excuse me. So whatever is denoted by HO, the null hypothesis, the opposite of that, everything that isn't the null hypothesis is the alternative. And then we're going to use information from sample data to test our two competing statements. Okay, so then there's this whole bit. My finger's getting tired. And then we're skipping type 1 error, and this is the last slide of errors. Okay. Okay, I'm just going to pause it here. Not with that button. Oh, geez. I'm just... Where is it? This one. Screen, black screen. Okay. All right. In fact, let's make me big. I don't know why I move my hands like the actual proportions are different. I just made the window larger, which this is blurry. I'm not streaming my webcam at full 1080p, so it's like 720, I think. It's not even, it's a square. Actually, it can't be 720 because that's a widescreen resolution. Anyway, I don't actually know what the resolution is, but hello. It's easier for me to speak to the camera because my screen's black, so I'm not as distracted. Okay, so this is imagination time, and this will help us build intuition about what we're going to be doing. Okay, so it might help you to close your eyes here. It's imagination time. It's like SpongeBob when he waves his hands in the air, makes the rainbow. Imagination. It's like that. Okay, so imagine yourself as the judge or a jury member, if you'd rather. And a crime has been committed. A not very nice crime, relatively speaking, of course. And a person convicted will serve a long sentence. Your main suspect, guy on trial, seems innocent enough. Pleading innocent, pleading not guilty, as they say. Seems above board, seems like he means it, doesn't appear to be lying. And behind him, small child, say 5-year-old girl, cute as a button. And you know that if you convict this guy, he's going to go to jail for the next 20 years. And his daughter will grow up without him. She'll have sleepovers and Sweet 16 party, go to prom, all without him. Go to college, come back from college, start her first job, all of that before he comes back. He'll be out of her life pretty much until she's a full adult. So, how confident Do you want to be that this is the guy that did it before you're willing to deprive this little girl of her father? I mean, don't get me wrong. Like, we want justice to be served. We want to get the guy off the streets, whoever's done this horrible thing. But how sure do you want to be? Remember, the burden of law is innocent until proven guilty beyond a reasonable doubt. In criminal law, anyway. It's beyond a reasonable doubt. Okay, what percentage of a guess is a reasonable doubt? We can agree it's not 50-50. Oh, yeah, there's a 49% chance that he's innocent. Oh, yeah, that's there's no way. Okay, that's pretty likely. Basically a coin toss. All right, how about like 20%? There's a 20% chance that he's innocent. I'll be doubting on that one as well. How about 10%? There's a 10% chance that he's guilty? There's still a reasonable doubt there. At some point, you say it's not a reasonable doubt anymore. I don't know, 95, 99%? Where do you draw the line? It's hard. It's difficult. So, what would be a kind of a strange way to do it, but you could choose your vote based on, you decide what percentage of what percent chance you believe that this man is innocent, and then you compare it to some value. When you decide that if it's not 99, if I can't be 99% sure, I'm not voting yes. Okay, well, how sure are you? 97% chance? Don't convict. Because it's a really, really big deal if you send an innocent person to jail. Not only have you robbed a daughter of her father, but the true culprit goes unpunished. And, potentially, can commit the crime again. So, we want to be really sure we're getting the right guy. We don't want to stop looking until we know we got the right guy. So, it's very important that we have a strong amount of evidence. And so that is exactly what we're doing here in hypothesis testing. So in my silly example here, our hypothesis, the null hypothesis, the assumption is that he's innocent. He is innocent until proven guilty. And unless we can show beyond reasonable doubt that the probability that the null hypothesis is true is very small, we cannot convict him. So that's what a p-value is. The p-value is the probability that the null hypothesis is true. So small p-values mean we reject the null hypothesis. We say, no, he cannot be innocent. He must be guilty because the likelihood that he is innocent is so small. So what do? We define a significance level. 95% corresponds to a significance of alpha, 5%. And then we see if our p-value is less than 5%. If it is, we say that the value of the test statistic is in the rejection region, which is really only helpful if you're drawing pictures. But, less than 5%, you reject. And there it is in math terms. Right to jail. I don't know if you guys have seen that meme. It's gotten popular I like to look at the website Imgur, which is associated with Reddit, if you don't know. And that GIF has gotten popular. Right to jail. From Parks and Rec. Okay, so interpretation. So what do we do with these p-values? Well, most of us can agree that if something is more than 99% chance of happening, like more than 99% likely, we're pretty happy with that. I would take most bets at 99%. If my life is on the line, then it gets harder. Like what's worth betting your life on? Some things, I guess, but if I'm thinking like just a cash, it's like, 1% chance that you die, 99% chance that you're set for life. It's like, you got to do something with your time. I don't want to die, so I don't know. Maybe I wouldn't take it. Who knows? Okay, so these are guidelines again. These are just suggestions. less than 1% chance that the null hypothesis is true, overwhelming evidence to reject the null hypothesis and conclude that the alternative hypothesis is true. Between 0.01 and 0.05, so we're less than 99%, but more than 95%. That's still really strong evidence in favor of the alternative hypothesis. Between 95 and 90% chance that the null hypothesis is wrong. Well, we're only calling it weak evidence at this point. It's still better than a 90% chance that the null hypothesis is wrong. And we're calling that weak evidence. So remember, I told you before we would use 90%, 95%, 99% are the 3 cutoff values that we'll talk about in class. This is partially why. These are acceptable, like, major increments. Does that make sense? So below 90%, greater than 0.1 for your P, insufficient evidence to conclude that the alternative hypothesis is true. So these are the 3 cutoff values that we're talking about in class. This is 90%, 95%, 99%. Overwhelming, strong, weak, and insufficient. Now, of course, sometimes you're willing to accept 85%. It depends on the context and how easy it is to get data. But usually we want at least 90% chance of before we reject a null hypothesis. Again, usually the cost of rejecting when it's not rejected, when it shouldn't have been rejected, is bigger than the cost of failing to reject when you should have. Usually. Okay. So here's a graphic. Remember, I encouraged you to draw pictures whenever you're doing z-table stuff, normal distribution type things, which this is what this is. We have a sampling distribution for x bar, and we're seeing, okay, how likely is it that we would have gotten a sample with an average of whatever if the population mean is in fact what we think it is? How likely is it? Okay, let me say that again, actually. So I told you the p-value is the probability of the null hypothesis being true. How else can I say this? The p-value is also more directly, like literally what's happening. It's what is the probability that if the population average and standard deviation are what we think they are, how likely is it that we would get a sample average of whatever we got if that population if it's actually coming from that supposed parent population? In this case, this example on the screen, we calculated that it was that the sample was 1.46 standard deviations below the mean, which is only a 7% chance. There's only a 7% chance of getting a sample that's this small compared to the mean. Only 7%. So that is weak evidence. And in this case, we've said that the alpha is 0.1, so it's good enough. And we will reject the null hypothesis. Now, if you look at the other end of the line, so at the top of these lines, these vertical lines here, you see a p-value, 0.07 and 0.1. At the other end is a z-value. So rather than comparing p-values, we can compare z-scores as well. We can say, oh, a cutoff value, a z-value associated with alpha of 0.1 is negative 1.28. Oh, well, that means if my z-value is less than negative 1.28, then I know my p-value is less than 0.1. And so any number that is more negative than this means that I can reject my null hypothesis. The trouble is, this isn't really any easier. Sure, you can use a table and remember what numbers are associated with this, but I really don't think that's an improvement, is it? Is that really any easier to do it this way? I don't think so. And here's the problem. There's a downside. If you're just using what we call, this is called the critical value approach, when you just compare what's going on here to what's going on here, is the z-value less or not? Or even if you do it with the p-values, either way. If I just say, is it smaller, yes or no, and I just report the yes or no part, you have no idea. Like, was it a close call? If your cutoff value is 0.1 and you get a p-value of 0.099, I mean, you still reject because it's technically smaller. But if it were just a hair higher, 0.001 higher, you wouldn't reject. Don't you think that's important information? Don't you, if you're going to be a decision maker, don't you want to know that it was just barely on the line? Because if all you do is say, yeah, we reject, we have enough evidence, then there's no difference between that 0.099, that's just a hair below the cutoff value, and 0.00001. They look the same. Whereas in reality, those are very different. So you're actually better off in the long run to report the p-value. And if you want to comment on rejecting the null hypothesis or not, sure. But it's most important actually to include the p-value because an educated audience will learn a lot about this relationship from that p-value that you don't get by just saying that it's a reject. Now, of course, if you're using a really restrictive alpha, like 0.01 or something like that, then it's at least the alpha is no more than, or the p-value is no more than 0.01. So, in that case, you can probably say, hey, it's significant at 99%. Yeah, we're pretty confident. But you're generally better off reporting the p-value. Okay, that's all I want to say about that. Of course, there can be lower tests or upper tests. The only difference on an upper-tailed test, if you're looking at p-value being, or your sample average being bigger than the mean, is when you look up this 2.29, for example, whatever your z-score is, when you look it up, it's going to give you a big number, like 0.989 in this case. Don't forget to subtract that from 1. Or otherwise you'll be like, oh wow, 0.989, that's not even close to 0.04. But it is. If you subtract it from 1, you'll see that it's actually 0.011, not 0.989, whatever. So that's one thing to remember. Here's the critical value approach. I talked about it a little bit. I'm not testing you on it. I don't want you to worry about it. It's just inferior. So, skipping it. Steps of hypothesis testing. There are 5 steps to hypothesis tests, and generally, this is going to be how I ask you questions about hypothesis tests. All right, so this is what you should expect. This is what you'll see in the practice exam. This is what you'll see in quiz 3 if you take that. This is what you'll see on the final exam. Okay, it will be in a format similar to this. Step 1, develop your null and alternative hypotheses. So this is where you have to start. You have to start with the hypotheses or else you're just out of luck. You got nowhere to go. So there will be a couple questions about the hypotheses. Specifying the level of significance. This will come from the problem statement. So at most, you'll have to subtract something from 1. Otherwise, it's just going to be given. Okay, collect sample data. Also given to you. Compute the value of the test statistic. Okay, that you actually have to do. That means compute your z or compute your t. Those are your 2 options. Okay, now you'll notice this p-value approach, and then there's a step 4 and step 5. There's a separate step 4 and step 5 for the critical value approach, but we're not doing that. So don't worry about it. Step 4. Use the value of the test statistic to compute the p-value, right? So that means I've taken my x-bar, I've taken my sample size, my standard deviation, whatever, plugged it all in, I got a z-value, or I got a t-value, and I'm going to take that and look it up on the table. I got a p-value. Okay, and then compare the p-value to the significance and see if the p-value is smaller. If it is, reject the null hypothesis. If it is not smaller or equal. If it's smaller or equal, reject. If it is not smaller or equal, then fail to reject. We haven't proven it. So let's say, for example, we're using a 95% confidence level. Well, your alpha is 0.05. So if you find a probability of 6%, you're going to fail to reject. right? Because 6% is greater than 5%. But 6% is still unlikely. I hope if someone ever offers you a chance to double your money with a 94% chance of winning, that you take it. You're never going to get those odds again. Even money with 94% chance, please take it. Right? That is very likely. But it's not good enough. So that's why we don't say like, oh, well, we've proven the null hypothesis. No, you haven't. You've just failed to reject it. Very important distinction. Okay. Critical value thing, example problem. The response times for a random sample of 40 medical emergencies were tabulated. The sample mean is 13.25 minutes. Okay, so two things here. Random sample, this is n equals 40, okay, or you might choose to just like, underline it or something, whatever. 40 medical emergencies, make a note of this. Okay, sample mean is 13.25 minutes. Mean 13.25, okay. Population standard deviation. Okay, we have population standard deviation. So I know this is a sigma known case. Of course, it says it at the top of the page. But, if you didn't have it labeled like this, how do you know? It says population standard deviation. Cool. Okay, so this is sigma known, and it's believed to be 3.2 minutes. Okay, and just a little check, make sure my units match up. Looks good. Okay, director wants to perform a hypothesis test. All right, 0.05. Oh, geez. Not highlighter. Eraser. 0.05 level of significance. Okay. To determine whether the service goal, goal, that's a key word, goal of 12 minutes or less. Okay, so of 12 minutes, that means we've got an equality. So equals or less. So we put these two together, and we know we're going to want less than or equal to. I'll make sure this is like, this arrow is getting out of control. Okay, so this combines with this, and we know, okay, it's got to be less than or equal to 12. Okay, so I know for sure that the claim that I am trying to verify or reject is that the null hypothesis, the claim my claim to be tested, is mu less than or equal to 12 minutes. That is the assumed goal, which means that the alternative to that is, there we go, the inverse, right? So remember, the equals always goes up top. Sometimes it has a less than or equal to, or sometimes it has a less than or a greater than attached to the equal to, but the equal to is always in the null hypothesis. Okay, and then whatever direction the swoopy is facing in the top half, it faces the other way in the bottom half. Or if there's no swoopy and it's just an equal to, then this is not equal to. Okay. So there are our hypotheses. Put this on the last slide. We just took this off the thing directly. 0.05. Compute the value of the test statistic. Okay. Same thing we did last chapter. Nothing new. However, for the sake of my assignments, remember to round. So that means we're going to round this. We're going to round this. And we're going to round this. 3 rounds. We don't have to round the subtraction because there's no reason to. 13.25 minus 12 is exactly 1.25. It's already going to be rounded for you. You don't have to round it. You can. It's not going to hurt you. But 1.25 rounded to 2 decimal places, 1.25. It's not going anywhere. So don't forget to round. I will put that on the problem statements. It'll say round all calculations. That's what it means. Okay, this gives us a z value. 2.47. And again, the reason we're doing this is because D2L is limited, and it makes me upset. And I'm a little bit mad about it. Okay, so z of 2.47. 2.47 is actually pretty big for a z value. And we find a cumulative probability of 0.9932, 99.32% chance of rejecting the null hypothesis. I mean, there's a 99.32% chance that the null hypothesis is wrong. That is very small. Okay. P-value, do the 1 minus thing. And this is one of the reasons we don't round to 2 decimal places off of the table. If you did, this would round to 1. Or I guess 0.99. 0.99, and then this would just be 0.01. So 0.01, if we did round this up, that number would literally have gotten 50% larger if we rounded that, which would be really bad. Where did this come from? Z-table. Z equals 2.47. Just look it up on the Z-table. Boom. You got it. And finally, final step, compare to H0. So we have significant statistical evidence to infer that the EMS system is not meeting their response goal. So, and that's really all this chapter is about. There's plenty more. We're like a third of the way through the slide deck. There's plenty of details. There's plenty of nuance. There's other versions, other ways to approach the problem. This is all we're going to do. We're out of time. So, that's all we have time for. We're out of time today. We're out of time, period. This is it. This is all we have time for. So, I gave you the standard deviation. I could give you the t-value. So I could, instead of giving you the standard deviation of the population, I could not. But that runs into some problems, and there's like nuance of how to fix it. And so I probably just won't. So I didn't put anything on the practice exam about it. It's not worth explaining. It's easy. In a computer, there's no difference here because you can just compute the value of the t-score. But we can't do that with a table. The tables aren't detailed enough. And so these tests are hard by hand. They're often inconclusive. You don't know if you should reject or not. So we're just not going to have time to worry about it. So this is it. This is the only new thing. All you have to know is, so basically all that we really covered today was, oh, hey, we can take the hypotheses that we developed in the methodology from last class, from Wednesday, and we can apply what we've learned in 6 through 8 to those hypotheses. That's what we learned today. So I can say it in one sentence, but it will take practice. So there is a Chapter 9 homework. It's due tomorrow. If you haven't done it already, there's a few questions to do. And then also tomorrow, starting tomorrow anyway, will be Quiz 3 available now. I will send out an email at midnight with the hopefully good news. Yeah, same for sigma unknown. It's just a little bit wacky because the t-table isn't granular enough. But yeah, if you have, especially if you have a computer and you can compute the t-statistic exactly, yeah, there's no difference at all. It's the same. I mean, yeah, you use the t-table instead of a z-table, but it's the same. There's no difference. So, I will email you at midnight with the good news. Hopefully, if you haven't done your surveys, both of your surveys, campus study, campus climate study, and end of semester survey, please. Will it be the same as quiz 2? No. It is new information. This stuff. Chapter 9. Format-wise? Yes, it'll be the same. Is it multiple choice? No. Format, same as exam as quiz 2. Ben's right. 2 minutes. That's all it takes. 2 minutes. 2 minutes later. I do not. I looked yesterday and we were close, but we weren't there yet. We had like 20 between my 3 sections, which I have like, I want to say I have like 80, something like 86 students, and I had 22, 25 if I hadn't done it yet. So we were at like 75%. But when I looked on Friday, this section was the least, that filled it out the least, I think. All right, either this was the least, and I think analytics was the most, and so my 379 section had the highest percentage, and you guys had the lowest. I could be backwards on that. Climate study is in the announcements. That's right. That's quick maths. It's actually 6.67. But, yeah. 6 2/3. So the way it works is it's quick maths. Yeah. It's 6 2/3 until you drop a quiz. And then you get to replace if you have a bad score, you get to replace it so it can be worth like quite a bit. I mean, I've seen this dropped quiz make like half letter grades easily, more on occasion. Like if you have a 0, makes a huge difference. So it's meaningful. So climate study is on the announcements. Syllabus and announcements. Right to jail. If you don't fill out the survey, right to jail. Oh, there you go. Coming through clutch. There are a couple links that work. I'm pretty sure this is one of them. That's it right here. And it is clickable in the Switch chat. Hey, you know what would be really, really, really mean? If I looked at what the percentage was and I didn't tell you. I wouldn't do that. All right. I'm going to be honest with you guys. You haven't made it yet. This is current. I just refreshed it. I emailed everybody yesterday. I can send another email, but 3.5 hours. I've never had a class not make it. So there may be I think are a couple students who haven't done anything since coronavirus, have just basically, they've like soft dropped out. We call it an unofficial withdrawal. It's a thing. I'll see how many of them there are. It may be that if I take them out, you guys will be there. But let's not risk it. If you're one of the 7, you're probably not, But if you were one of the 7, fill it out. What is the climate survey about? It is about the climate at NEIU, as Ramzina said. Personally, to me, that doesn't make a lot of sense. To me, climate is like weather. It's like, is it raining? Is it cold? It's more like, is it hostile? It's like it's basically trying to diagnose what the environment is like. What's the, in a sentence, it's, what is it like to be on campus at NEIU? What's it like to be a student? What's it like to be a faculty? What's it like to be a staff member? What's it like to be, a person who works in the janitorial services or the cafeteria ladies, So the questions are things like, have you ever felt like you were discriminated? Have you ever seen someone be discriminated against? Have you ever Have you ever experienced sexual harassment or anything like that? So there's a huge list of like definitions and terms at the beginning that you can read through if you want. It's a lot. It's dozens of words. And you've probably heard most of them, but it's good to refresh yourself. How long does it take? It depends on how much you type and how fast you read. Surveys are really hard to judge. I almost always take mine like 2 to 4 times as fast as people tell me I will. So I don't use my own experience as a judge. The official statement is 20 to 30 minutes, or however long you spend typing at the tell us your thoughts blanks, because there are some like open-ended text boxes and you can type whatever you want as much as you want. And so you can spend as long as you want typing, Then don't mess with me, man. It hurts so much, please. No. It's so true. I mean, like, so what sucks is, like, there are people who genuinely have, like, really horrible problems right now. Like, they have the disease. Their family has the disease. They're job hunting. They got a new job, so they're working 12 hours a day. Or, like, I've got a student in one of my other classes, doesn't have internet. He is taking business analytics, and he's done all his work on campus the whole semester. Perfectly fine. Like, not an issue. And then coronavirus. He can't go to the library anymore. So it's real bad. Oh, actually, I meant to talk about that. Okay, so, oh man, it timed me out. Of course it did. Cool. So, point estimator is literally just like the mean. So, anytime, this, by the way, this is just a term, So, I wish this loaded faster. Okay, where is it? This one? This one? This one? This one. Okay. Oh, yeah, the one that says A to Z on it. All right. P. Give me a P. P. Give me an O. O. Give me an I. I. A sample statistic, such as X bar, S, S squared, P bar, whatever, that is used to estimate a corresponding population parameter. So literally all you do for the point estimator, it's just the mean, whatever the estimated mean is. So on the quiz, on the in-class assignments, on the exams, whatever, if it asks you what's the point estimate, whatever it says mean, wherever it says mean in the problem statement, you just type that number. It's that simple. The point estimate, so S is a point estimate for the standard deviation, not X. The mean is the mean. X bar is the estimate for the mean regardless. And S is always the point estimate for the standard deviation. But if we already have the standard deviation, we don't need to use the point estimate S because we have the actual thing. So there's no reason to use an estimate. We don't have the population mean, mu. We never have that. That's the whole point of hypothesis testing, is we're estimating it, but then we're going to be asking ourselves questions about, what's the probability that it's this or that it's that? Is it right? Did it get marked correct? So, some of that is right, some of that is wrong. So it's half and half. So more or less, Ben. Yeah. So so we're always going to have samples. It's always going to be suppose a sample blah blah blah. Suppose a sample blah. But in the question that Mo copied in. So resulting in a sample mean of 950 and a sample standard deviation of 95. So if you keep reading and it says the population standard deviation is estimated to be, well, good, you've got the population standard deviation. If I don't give you the population standard deviation, but I give you this. So if I give you both, use population. If I only give you population, use population. If I only give you the sample standard deviation, then you have to use S and you use the T statistic. You use the sigma, you use with the Z anytime you can. If you don't have that, you have to use S. So, I don't know what the answer is off the top of my head, but if I had to guess, if it's not just an entire mistake, it's a rounding issue. So I have to go back and do that manually. I don't know all the answers. But so in the example, yeah, Ramsey-Nun's right. It's a T. You have to find the T statistic associated with alpha over 2. So alpha is 0.05 because it's 95% confidence interval. So you divide 95, 1 minus 0.95, 0.05 divided by 2 is 0.025. You look that up for a sample of size 11, which gives you 10 degrees of freedom, 11 minus 1. And then you look up 0.025 on the T table with degrees of freedom 10. And then, of course, so that gives you your T value. Yeah, that's the... Yeah. The 95 is the sample standard deviation. That's S, not N. It's easy to do. There's lots of numbers and stuff in there. So you get the t-score, and then you divide or multiply by you can email her, you can email me, and you can email the tutors. Remember that they are there for you as well. All those are options. Oh, I still have the YouTube video recording. Oh, well. Well, if you're still here, maybe you're bored. I don't know. But thanks for checking in. It's been a good one.